Okay, so we've graphed the exponential function, but really what we need is the inverse of this function. So we're going to exchange our x and y values back. So I'm just going back to my table and showing you these are the new ordered pairs that I'll be graphing in order to graph the logarithmic function. So I've just exchanged my x for my y, and I'm going to go back over here to graph that. So I will graph 1, 0. I'll graph 2, 1, 4, 2, going to 8, 3, and to see what's happening right here on my graph, I'm going to graph 1/2, -1. Now if you can notice, this is the inverse of that function. So I have a different type of asymptote here. My asymptote is actually going to be this vertical line here. So the asymptote will be where x is equal to 0. And looking at the domain, how far left my graph goes, it's approaching 0 but not quite reaching it. And it will go to infinity. And then for the range, how far down it goes down to -infinity. And it will continue growing, so it goes up to positive infinity. And this is the logarithmic function that I've just graphed. Okay, to continue, we're going to do some transformations now of those functions. Sorry, here we go. So it becomes a little bit more tricky, so we're going to do the same process to begin with. We're going to first, let's look at this graph. The function is y equals log base 3 of x minus 2 minus 4. And those transformations will be the same as they were before. Our transformations here are going to be that it goes down 4, or let's start here. It goes right 2, and it goes down 4 units. Right? The parent function is going to be the most basic function, where it's log with a base of b. So we would have log base 3 of x would be that basic logarithmic function. Now we're going to rewrite it as an exponential function, which would be 3 to the y power is equal to x. But to help us graph it, we're going to use the inverse of that function, which is y, the inverse of y, 3 to the x power. And you can graph that by using your calculator to find the table, or you can pick some values and plug them in for x and then solve for y. So if I plugged in x, I know y would be 1. If x is 1, y is going to be 3. If x is 2, y is 9. -1, remember that's going to put that as a fraction. And -2 would be 1/9. All right, and I can go ahead and graph this. This is the inverse function, so it's 0, 1. I have 1, 1, 2, 3. I have 2, 9. And I have -1 and 1/3. And -2 and 1/9. So it's always approaching. And this right here is without any transformations, the inverse function. So remember, I want to flip my x's and my y's, and I'm going to stick with my purple pen color so you can see it better. So I'm exchanging the x's and the y's, so now I'm graphing the point 1, 0, then 3, 1, 9, 2, 1/3, -1, and then 1/9, -2. I'm just going to plot the points. I'm not going to connect them at this point. So I have 1, 0, 3, 1, 9, 2. I have 1/3, -1, and I have 1/9, -2. Right now, these points are the logarithmic function, the parent function of log base 3 of x. So what I need to do is now do my transformations. Remember, my transformations are in order, so I would use the to the right 2, 1, 2, and then I go down 4 units. Here I'm going to go right 1, 2, and I go down 4 units. right 2, 1, 2, 3, 4, right 2, 1, 2, 3, 4, right 2, I'm over here, I'm extended a little bit off my graph, but I want you to be able to see it, so it's 1, 2, 3, 4. Fix that point right there. Right, so here's my graph, and this is the graph of the function log base 3 of x minus 2 minus 4. And here's the graph right here. Notice it's always approaching but never reaching this vertical line where x is negative 2, and that's our asymptote. And looking at my graph, I can tell that the domain, how far left it's going to go, sorry, that should be a positive 2, excuse me, would be 2 less than x, and then less than infinity because it continues going right. The range, how far down the graph goes, is negative infinity, is less than y, is less than infinity because it continues growing.